In this video, we're going to be building a foldable, and this is an example of one that has been completed. So when you look on the inside, there will be different information that we will be covering. We are going to be doing this foldable in 4 separate videos so as not to take so long. So the first thing we need to do is you need to take your piece of paper that has the markings. If you notice, the markings are on both sides of the paper. Okay? So what I want you to do is I want you to take the edge that has the markings closest to the edge. So if you notice, there's not much space here, but down here there's a lot of space. So we have to cut this into a square. So that means we're going to take one of the uppermost corners and we're going to bring it over to the side edge such that the edges align themselves nicely and we get pretty much a perfect corner there. We have to make sure our edge aligns perfectly, okay, as best we can. And then if you just take your finger and slide it down the crease, that should be good. Okay. So if you notice, if you folded it the way I folded it, that you have this triangle on this side, and there's a little bit of wording that's coming off on this side, but don't worry about it too much. So we have to cut off this excess. So go ahead and take your scissors and as carefully as you can, right on the edge, just go along that line. And cut that part off. We don't need this part. We can throw it away. And so now you have created a square. Okay? So what we're going to do is we've got to fold this a certain way. So let's put the graph on the inside, and along the crease that we just created to make the square, fold it the other way. So now you have the words on the outside and your graph on the inside. Okay, so once you've done that, go ahead and open it up, and we're going to fold it again, corner to corner, lining up those corners as best we can. So we have a triangle that way. So these creases are just going to help us to do the next motion. So we're going to open it up so that we can see the creases on the inside. So we're going to take this corner and we're going to put it in what would be the origin of those lines where they meet. Okay, so it looks like that. It's just a little bit of origami for you. And again, we're going to bring that corner right to the center. Try to make sure it's all lined up nicely. Otherwise your foldable won't look very good, won't open very good. And we're going to do that all the way around, making it point to the corner, and then the last one should fit in there real nicely, and then you should have the outsides so that they all face in like this. Okay, so the only thing we're going to focus on in this video is domain and range. So let's pay particular attention to domain and range. I'm going to zoom into that section. We will be writing some things in our notebook as well because I have to talk to you about a certain notation for domain and range. So the first thing I'm going to talk about is domain. I'm going to highlight that word in green. And domain is all possible input values. So I'm going to write the definition. All possible input values. Okay. So if you recall, range, which I'm going to highlight in red or pink, whatever color this is. That is all possible output values. Okay? So you can think of output as your answer in a way. So this is what goes into my function, and this is what comes out of my function. So we typically can also write, we think of domain as the coordinate values, and sometimes there's just one value, and sometimes there's an infinite number of values. So my x, that is my input, and my y is my output. Okay, so that's all pretty much review for the definition of domain and range. But let's go ahead and let's look at the graph on the inside. So let's turn this so that the graph is facing in such a way that we can see it clearer. So let's talk about domain first, because domain is our input, and we have to have an input in order to have an output. So down here at the very, very bottom, leave some space. I'm going to, because we're going to write some things above it, I'm going to write domain. So domain, when we're looking for domain on the graph, we're going to be looking from left to right, okay? Because the domain, the ruler for the domain is on my x-axis, okay? So remember, if I want to look for the value of x, I'm looking along my x-axis. I'm moving left to right. So what I want you to do is I want you to draw beneath this graph, I want you to draw a line. So let's just pretend all we have is the x-axis, but we're going to draw it down there, okay? Now, way, way out here to the left, as far as I can go, if I could keep going forever, this is where x would be negative infinity, and way out here on the right, if I could go forever, x would be positive infinity. Okay, it approaches it. And then I have every single real number in the middle. Okay? So when I want to know what my x value is, for example, if I wanted to know what my x value is right here, I would have to look up to my x-axis to see what that value is. The same thing for a point right here. I would have to look up to my x-axis. Here I would have to look down to my x-axis and so forth. So when we're looking for domain, take your ruler, and your ruler always has to touch the x-axis, okay? So if you notice, my ruler is vertical. It is always touching the x-axis. So I'm going to start as far left on this function as I can to figure out what the domain is. However, that is not where this function starts. And in fact, this graph is a little deceiving. I seem to have misplaced my black pen. This graph, it keeps going down, and as it's going down, it's getting wider. If I could keep drawing this, it would eventually be way out here. It keeps getting wider and wider and wider. So this actually starts as far left as negative infinity. And as I'm moving my ruler, notice that it's touching the function, it's still touching the function, it's still touching the function, up until this place right here. At this moment here, my function has no x values between here and here. There's a gap. I'm going to put a line right here. Okay? So, the question is, right here, what's the value of x? The value of x right here is -4, so I'm going to write -4. Okay? So far, what I'm telling you is everywhere here is the domain. all those values on that number line to the left of negative 4 is the domain, because that draws that value, that function right there. Okay, but we're not done. Wait, there's more. So when I'm looking at my ruler here, it's not touching any part of the function. There's a gap. But then it starts up again right here. So right here, I'm going to put another vertical mark, and that's where x is negative 1, 2, 3. That's where x is negative 3. So when I take my ruler, starting at negative 3, and I keep moving it, it keeps touching the function forever, even when I get here. This actually keeps going up forever, so that means it keeps getting wider forever. So that means that there is no end to that function, so it keeps getting wider. So that means all these values here of x can also be my input. Okay? So another way to think of your domain when we talk about left to right is we can also ask ourselves, how wide? How wide is that function? Where's the furthest left? Where's the furthest right? And it's everything in between. Okay, so when we look for our answers, here my value of x, which was my input, is in the green area. So if I were to write this as an inequality, here x is less than negative 4. So let's just write that here. X is less than negative 4. And here, x is greater than negative 3. So x is greater than negative 3. Okay, so that there is my domain. But I want to, actually, I'm going to go ahead and do the range. There was something I wanted you to do in your notebook, but I think I'm going to make a separate short video on that so this doesn't get too long. Okay, so that's my domain, very simply written. So let's go ahead and look at our range. Well, if our domain are our x values, and that goes from left to right, then our range must be top to bottom. So let's up at the top here, we're going to write the word range. And we're going to actually go from bottom, because the numbers on the bottom are smaller, to top. Okay, so that means that I'm only looking at the y-axis. So right here, I'm going to go ahead and draw my y-axis off to the side. Okay, because remember, your axis is nothing more than a ruler. That's all it is. It's giving you a measurement. So way down here on the bottom, my y value, if I could keep going forever down, would approach negative infinity, and if I could go up forever, it would approach positive infinity. Okay, so let's see. If I want to determine my range, I need to know my y values. So to find my y value, where do I look? I always look across to find my y value. My ruler always has to touch the y-axis in order for me to determine my y value. Okay? So that means I'm going to start at the very, very bottom. Well, the bottom isn't here. Remember, this xy coordinate plane is only showing me a part of the function. So I'm going to start with, this arrow keeps going down. So actually my function's way down here. So it looks like my function starts at negative infinity. And it keeps going up, and it keeps going up, and it keeps going up. It doesn't stop here. It keeps going up. It just so happens that I have two y values there. And I keep going up, and up, and up, and up. It's still touching the function. Here it's touching it in 5 places. 1, 2, 3, 4, 6 places. Okay? So it's still touching the function, and And it doesn't stop there. It keeps going because, look, the function keeps going up. And it keeps going up, and it keeps going up, and it keeps going up. So it keeps going up forever. So in this case, my range from the floor to the ceiling is everything. There's no gaps, there's no beginning, and there's no end. So what would we say? We would say that our range is all real numbers. And we could write it as negative infinity is less than y is less than infinity. Okay, so I'm going to go ahead and stop this video here, and I'm going to talk about in the next video interval notation and set builder notation based on this graph.